Hello all, we are into our next topic on solving single-step linear inequalities. And so yeah, like we did in 9.1, we're gonna be looking at a range of solutions, or in other words, an infinite amount of solutions is another way of describing it. And the first thing we're gonna do is show you how to verify your solutions. So when we're solving them, it's very, very similar to how we would solve a linear equation. So solving these linear equalities, very similar to solving linear equations. I want to isolate my variables, get it alone, make sure it's upstairs, positive. And so if I was looking at something like this, x take away 3 is less than -5, I'm still going to think about it the same way as a linear equation. These relations and equations, inequalities and equations are very similar in some ways. This is one of the ways. So I still want to get x by itself. I still want to add 3 to both sides. And after I do that, my 3's would cross off, and I would have x is less than -2. And so what this means, if I was to put this on a number line, so I have 0, -1, -2, -3, -4. What this is saying is that x is less than -2. So if I think about how we represented these graphically in our last topic, I want to put this boundary point at -2, and my values of x are anything less than -2. So I would draw an arrow, I would point it this way, showing that x is any number less than 2. So to verify, to make sure that I have done this correct, what I want to do is, I want to, first of all, there's two things I have to do. One, I got to check this boundary point. I got to check this point where I've made a circle at -2. And to verify, I want to use the original inequality, but in this case, I want to think of it like an equation. I want to see if the left-hand side equals the right-hand side. So I would write x minus 3 equals -5. Even though there's a less than sign there, it's an inequality, I'm using equal sign because I'm only checking one point. That's this point here where the circle is. I would use my solution as -2, substitute that in for x. And what we see is that the left-hand side does equal the right-hand side. If I went -2, take away 3, I get -5. I got -5 here. That tells me only one thing, that where I've drawn this circle is correct. There's one more check I have to do. I want to see if this entire range of values is correct. So what I'm going to do is I can really pick any value that's less than 2. I could pick -3, -4, -5, whatever. You get to choose in this case. I guess one helpful hint I might give you, if you have the choice of choosing 0, I would do it because 0 is an easy number to work with. But in this case, I don't have that option because all my values are going that way. So I'm going to pick -3. In this case, I do want to use the inequality sign. So here's my original equation. X minus 3 is less than -5. I'm going to choose -3 because it exists on that line. And then I'm going to go -3, take away 3. And then I want to check if the inequality is true after I do this. And so -3 take away 3 is -6. Is -6 less than -5? Yes, it is. So I know I've done this correct. One more example. And I think something funny is going to happen here, but let's try this anyway. if this was an equation, I would solve by dividing both sides by -2. After I do that, I get x is less than or equal to -4. Okay. So I'm just going to represent this solution graphically, and I get my boundary point is at -4. It's a closed circle because it's less than or equal to. My values of x are got to be less than -4, but also including -4. So they're also going this way at first glance. Like I said, something terrible is going to happen. Is the boundary point correct? Let's check it out. Are the left-hand side and right sides equal? So I would go -2x, is it equal to 8? I'm going to go -2 times -4. Negative times the negative is a positive. 2 times 4 is 8. This boundary point is 100% correct. Let's check the range of values. All of these values over here. I'm going to pick -5. Exists on this blue line. So as I go to do this check, I'm going to go -2x less than or equal to 8. I'm going to put in this value of -5 that I've chosen. -2. I'm going to check if it's true. Negative times the negative is a positive. 2 times 5 is 10. Is 10 less than 8? No, it's more. So I noticed that something has gone wrong here. There's some type of mistake that has happened. And so what went down here? I did the solution. I divided by -2. That's what I was supposed to do. Why is this not right after verifying it? You're going to find out today. So as a little example, we have 2 is less than 5. Most people would probably agree with me that that's true. Let's see what happens if I add 2 to both sides. So if I add 2 to both sides, I would get 2 plus 2 is 4. If I add 2 to 5, it's 7. Is 4 less than 7? Yes, it is. Adding didn't really do anything to make it untrue. I'm going to add -3 to both sides, or take away 3 from both sides. So if I was to do that, whoops. I get, if I take away 3 from both sides, I would get -1 is less than 2. Is -1 less than 2? Yeah, that still works. So there's no issues with adding a negative. Multiplying both sides by 5. 2 times 5 is 10. And 5 times 5 is 25. Is 10 less than 25? Yes, it is. There's no real issue there. The next thing I'm going to do is multiply both sides by 25. 2 times -5 is -10. 5 times -5 is -25. Is -10 less than -25? No, -10 is more. This is of greater value. If I was to put this on a number line, -10 would be to the right of -25. This is a bigger value. So what went wrong here? Well, what we see happening, and one of the key ideas that you guys need to take away from 9.2 is that there's one exception that needs to happen when solving these equations when we're either multiplying or dividing by a negative number. And so whenever we're multiplying or dividing by a negative number, we must flip the inequality sign, or else it will not be true anymore. Hopefully based on the reasons that we just talked about and that example. So if I was to solve a linear inequality like this, I would add 1.6 to both sides. Oops, I didn't really need to draw this. Okay, so I'm making a 0 here, and I would get -4. That's how I would solve that one. In this case, I have x being divided by -8. In this case, I'm going to multiply both sides by -8. As soon as I've multiplied by a negative number, I'm looking at this inequality sign and I'm going to reverse it. It must switch directions. Now I'm getting x is less than -24. Last one. I have -10 is greater than 4x. I'm going to divide both sides by 4. Since I divided by a positive number, I'm not going to switch the inequality sign. And I just get -2.5 is greater than x. So I'm using the same strategies to solve these inequalities as we did with linear equations. The only difference is that we have to switch the inequality sign when multiplying or dividing by a negative number. That's the big idea here. Okay, so like we talked about at the beginning, we're going to have to verify, we're going to have to do some checks, and so step 1, I want to make sure that boundary point's correct. Step 2, I'm going to check the range of values. So in some of our questions, we're going to be asked to verify some solutions. So here's my original equation. Here was a solution that somebody came up with. And so the first thing I'm going to do when doing my check is I'm going to check the boundary point. I'm just going to call it BP. So I'm going to use this original equation, but everywhere I see it, everywhere I see an x, I'm going to put a 20. 20 minus 12, is that equal to 20? Remember, if I'm checking boundary points, I can use that equal sign even though we're dealing with inequalities. Does 8 equal 20? Nope. So right away I know that the boundary point is not correct. This solution is therefore for sure not correct. Let's look at the next one. So yeah, once I know, sorry, I'm going to go back to this. Once I know that the boundary point is not correct, I'm not even going to do the second check because I know already this solution is not right. I have a second inequality right here and its solution. Again, the first thing I want to do is check the boundary point. So everywhere I see an x, I'm going to put a -6, -5, -6. Does that equal 30? Negative times a negative is a positive. 5 times 6 is 30. Does that equal 30? Yes. The boundary point is good in this situation. The second thing I want to do is to check my ROV. That stands for my range of values. I want to make sure that that's all good. So I'm going to look at the solution. So to do this, I'm going to look at the solution and I want to pick a value of x that is less than -6. I don't want to choose exactly -6. I've already looked at that in the boundary point. I want to pick a value of x that is less than 6. So I'm going to go with -10. It's easy to multiply things by tens, right? Just add a 0 onto the end. So I'm going to pick -10 and use the inequality sign. -5 times -10, is that less than or equal to 30? So I'm going to go negative times a negative is a positive. 5 times 10 is 50. Is 50 less than 30? Nope. 50 is more. So I know that this solution is not correct. And the most probable cause in this case, since the boundary point was good, is that the person, well, I'm guessing looking at this, would divide by -5. This person who solved this most likely and did they forgot to flip the inequality sign when they divided by a negative. So again, if you were daydreaming during most of this video, the key thing to remember is solve these inequalities as you normally would, with the exception of if you are multiplying and dividing by a negative number, you have to flip the inequality sign. There's some homework questions for you. I will also post your assignment on Google Classroom. That's all for now.